This is a tutorial to help you complete homework number 4. The directions for the first question state to describe in words how to locate the following coordinates. So the coordinate is 2, negative 7. And the first value is always the x coordinate value, and the second value is always the y coordinate value. So if I think about this on a coordinate plane, the point 2, negative 7 has an x-coordinate value of positive 2 and a y-coordinate value of negative 7. Therefore, if I start at the origin and I want to get to this location, I would need to move 2 units to the right and then 7 units down. So 2 units to the right and then 7 units down. That's how I would describe the location of this point, how you move from the origin to get there. So you can write the word out in English, 2 units right, or you could write the number out as a numeral, 7 units down. That's how I describe in words how to locate the following coordinate. For number 2, the x-coordinate is positive, so we would move to the right. The y-coordinate is positive, so we would move up. Remember your axes. X is horizontal, left to right. Y is vertical, up and down. So here I would write 5 units right, or 5 units to the right, and 1 unit up. Number 3, my x-coordinate is negative, and if you're moving negatively on the x-coordinate, you would be moving left. And if you were moving negatively on the y-coordinate, you would be moving down. So for number 3, the x-coordinate is negative, so I would move 89 units left. And 49, my y-coordinate is positive, so that means 49 units up. So this part of the lesson is checking to see if you know how to move along the coordinate plane left, right, up, and down. So for question number 4, the final question here, both my x and my y's are negative. So I would move 63 units left, because left is negative on the x-axis, and 51 units down. Now let's review our quadrants. So here on the coordinate plane, when your two axes intersect, they create 4 separate sections. Those are called quadrants. Quadrant 1, all points are entirely positive. In quadrant 2, only the x-coordinates are negative. In quadrant 3, all points have negative coordinates. And for quadrant 4, only the y values have negative coordinates. So for question number 5 here, if I move 8 units on the x-axis, 8 units would be to the right, and then I move negative 9.4 units on the y-axis, negatively. If I move positive on the x and negative on the y, I would be located in quadrant 4. Question number 6. If I'm going to move positive 18 units on my x, that would be positive and positive. If everybody's positive, right and up, I would be in quadrant number 1. For question number 7, all coordinates are negative. So negative movement along the x-axis, negative movement along the y-axis, that would land me in quadrant 3. And for question number 8, the x-axis, the x-coordinate here is negative. So I would move negatively along my x-axis. And even though it's a small number, my y value is positive. So I would move upwards from there. That puts me in quadrant number 2. That's how you determine the quadrant in which a point lies. Second box, graph the coordinates on the grid below and label it with the correct letter. Remember, the x-coordinate is left to right, and that's your first movement. The y-coordinates are up and down, and that's your second movement. So here, each of my values has an x-coordinate listed first and a y-coordinate listed second. So if I travel 0 on the x-axis, then as I'm moving, I would go nowhere left or right. So from here, I go nowhere right, nowhere left. I stay lined up with 0 on the x-axis. But then I need to locate -5 on my y-axis. So I need to move down 5 units. And that's where my first point will be located. Label it with the letter you were given. That's point A. Question 10. My x-axis number is 1. My y-axis number is 6. So the x-coordinate is located 1 space from 0, and my y-coordinate is located 6 spaces up from 0. So from the origin, I move 1 unit on my x-axis and up 6 units on my y-axis, and I make my point and label it with the letter given. Letter C, -1 on my x-axis and -3 on my y-axis. So -1 along my x-axis, -3 along my y-axis, and label it with the coordinate given. Question number 12. Letter D, 0 on my x, 4 on my y. 0 along x, so no movement along x, +4 movement along y. Label it with your letter given. Letter E, -3 along my x-axis, so -3 along my x-axis and 0 on my y-axis, so no units up or down. So I would remain on the axis. Last question. Letter F, 4 units for my x-coordinate, 4 units from the origin, so 4 along my x-axis, and then up 2.5, up 1, up 2, and halfway. So I'm going to put my coordinate right there in between the grid marks. Label my letter F. And that's how you graph coordinates on the coordinate graph. Alright, let's solve a couple of equations here using our distributing, combining, addition properties of equality and division properties of equality. So here I need to distribute to clear these parentheses first. Rewrite my equation as 2x minus 8, and then my new side over here with no parentheses would read 15x minus 6. My x's are on different sides of the equal sign, so I cannot combine them. But I can use the additive inverse to join them together on the same side. So when I rewrite, I'm going to get -8 equals 13x minus 6. I'm going to add my constants on both sides here. I'm going to get 13x is equal to -2. I'm going to divide by my coefficient, and -2 cannot be divided by 13 evenly into a decimal that ends, so I'm going to leave it in fraction form. My final answer is -2 over 13, -2/13. Okay, I'm going to take this work, I'm going to shrink it down a little bit so that I have some room for my next question. There we go. Question number 16. I have variables on both sides, and this is a new question for you. We're going to talk about this at the end of the week. So if I subtract 4x from both sides, which I'm allowed to do, I actually get a cancellation on both sides. And that leaves me with 6, +6, is equal to nothing. And this statement that 6 is equal to 0 is not true. It's not true. So you would need to place this mark over the equal sign to show that you understand that 6 is not equal to 0. Whenever you're solving an equation, if your variable actually disappears on you, right? I had an x on the left and an x on the right, and now I don't have any x's at all. That's a special situation. It gives you a special answer. So if the statement that you end up with here is not true, then you simply write that there is no possible solution. All right, let's take a look at number 17. I'm going to subtract 3x from both sides here. I'm going to rewrite my problem, and now I'm going to divide by my coefficient. Nice and easy here. X is equal to 2. All right, for question number 18, if you have a fraction as a coefficient, you're going to distribute it 2/3 times x. X has no value here, so 2/3 times x just remains 2/3 x. And 2/3 times 12 means 2 times 12, which is 24, and then divide by 3. So you only multiply the numerator. 2 times 12 is 24. 24 divided by 3 is 8. And then I rewrite the rest of my question. Simple two-step problem here. 2/3 x is equal to 0. That can happen, right? That can happen. 2 cancellations on both sides gives you a 0. And now my coefficient is a fraction, so I need to multiply by the reciprocal. But the good news is, even though I had to flip that fraction over, which can be tough, is that when I'm finished, anytime you multiply something by 0, the answer is always 0. Okay, question number 19. I have 2 terms on the left, but I cannot combine them. I have 3 terms on the right, so I need to combine some of them. This is not a subtraction question. This here, when they're on the same side, means you just do the math that you see. So let me rewrite the left side, 6x plus 4, and let me combine the right side. 12x's minus 5x's is 7x's. And I rewrite my plus 4 at the end. Now I have to get my like terms together, but since they're on different sides, I have to move them. So I'm going to move this smaller x here, and that allows me to keep my x's positive, right? 1x plus 4. So I'm going to subtract 4 from both sides. Again, this can happen, right? You get zeros on both sides, so 0 equals x. 1x here, so I left the 1 invisible. You're allowed to do that. Now this is different than this question up here with number 16. Take a look. This one has a letter, a variable of x is equal to 0. That's an answer. 0 is a number. But in number 16, there was no x. The x disappeared. That's why I got this special answer of no solution. Just because you have an answer of 0 does not mean it's a no solution question. All right, last one. Some decimals here. 0.3 times x is 0.3x. 0.3 times 1 is 0.3. And negative 24 remains the same. So for this question, I'm going to subtract 0.3 from both sides. And that actually gives me negative 24.3, because when the two signs are negative, you add together. Same signs add together. Different signs subtract. Take the sign of the larger number, then you'll be exact, right? So let's clear this coefficient by dividing. And I get our final answer here of negative 81. Okay, last section. Create a graph and label each axis here. So my graph has minutes and number of bacteria. So the graph is minutes is the x coordinate, bacteria is the y coordinate. Remember, x is horizontal, y is vertical. So let's see what kind of scale I want to use here for my x values. It looks like I have decimal values. So I'm going to want to go by 0.5s. So my first one cannot be 1 because I want to go by 0.5. So my first one has to be 0.5. My second one can be 1. This one can be 1.5. This one can be 2, 2.5, 3, 3.5, 4, 4.5, and my last one can be 5. So if I label this axis, this would be minutes, right? And over here, my y-axis would be number of bacteria. And it looks like I need to go all the way up to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep, I did a little check there. It looks like going by tens would work. Now I can label all of them, but I don't have to. 10, 20, 30, 40, 50, 60, 70, 80, 80, and 100. So my title would be number of bacteria over time, right? That's what I'm showing here. How many bacteria I have over a certain amount of time. So now I'm ready to graph. After 1 minute, which would be this value, I have 20 bacteria. After 1.5 minutes, I have 30 bacteria. After 3.5 minutes, I have 70 bacteria. And after 5 minutes, I have 100 bacteria. And if your graph is not coming out straight, you're doing something wrong. That's how you complete homework number 4.